Hi everybody, I am Dr. T. Miranda Lakshmi, working as an assistant professor in the Department of Computer Science, St. Joseph College, Cuddalore. Today we are going to discuss about deadlocks. So already in this process management, we have discussed about the process state transition diagrams, levels of scheduling and short-term scheduling methods. What is by a deadlock? When this deadlock will be happening in your system? When your resources are not shareable, this deadlock will happen. What are called as resources? Resources are like printers, tape drives, plotters. So these are called as resources. In a system, some resources will be shareable and some resources will not be shareable. If the resources are shareable, then the deadlock will not occur. If the resources are not shareable, then the deadlock will occur. So let us take a real-time example. If two persons are there, person A and person B. Person A is having pen and person B is having notebook. If person A is waiting for this notebook and the person B is waiting for this pen, this will not happen. Either they have to share. If they are not going to share, then the deadlock will occur. Similar situation will be happening in your system also. If the resources like memory can be shared by more than one process. So at that time the deadlock will not happen. But if you're going to take resources like printer, tape drive, plotters, these resources cannot be shared by more than one process. So let us consider an example that we are having two processes, PA and PB. So PA is using a resource R1, that is, let us consider it as printer, and PB is using a resource R2, it is tape drive. Let us consider that PA is request for R2 without releasing R1. So PA is using which resource? This R1, that is printer. It is using R1 and it is requesting for R2 without releasing this R1. Similarly, PB is requesting for R1 without releasing R2. This strange situation is called as deadlock. So deadlock will be occurring when the resources are not shareable. So deadlock can be represented using a graph called as directed resource allocation graph. In short, they'll be saying this DRAG. So what will be present in this direct resource allocation graph? We'll be having two symbols. One is hexagon, the other one is rectangle. Hexagon is used to represent the process and rectangle is used to represent the resource. So here if you're going to take this example, here PA is a process which is using resource R1. If in the above diagram, this arrow mark is indicating to this hexagon. If this arrow mark is indicating to this hexagon, it indicates that PA is using the resource R1. Similarly, if see this diagram, in this diagram, PA is requesting R2. Here the arrow mark is being focused to this rectangle box. If this is the case, here you are going to request R2. Okay, so these are the two different diagrams. So hexagon is used for your process and the rectangle is used for your resource. Here this resource, here what you're going to do is PA is using the resource R1. If the arrow mark is changed, then we can say it as PA is requesting for the resource R2. Now with this we can draw the diagram for deadlock. See here, we have considered two cases, that is PA is using resource R1 and requesting for R2. Similarly, PB is using the resource R2 and requesting for R1. See here, I have drawn two diagrams, that is one hexagon, the other one is rectangle. So in the hexagon, I have given us process PA and process PB. And in the rectangle, I have given us R1 and R2. Here PA is using the resource R1. So you are given the arrow mark here. Similarly, PA is requesting for R2, so we are given the arrow mark in the rectangle box. If you are going to consider PB, PB is using the resource R2, so the arrow mark is near the hexagon, and PB is requesting for R1, so the arrow mark is in the rectangle. So using this drag, what we are going to conclude is, if you are going to start it from here, so it is starting here and it has formed a closed loop. So if you are going to traverse to the arrows, it will be finishing at the starting node itself. So this is called as a deadlock. Thank you.